Once again we have a rod of mass m, length L and uniform mass distribution. Earlier this rod it could move in the horizontal circle. Now this rod it can move in the vertical circle. Once again it is pinned over here and the force is being applied perpendicular to this original length position, that is in a direction perpendicular to this, and it is being continuously being applied in this direction only, always being applied in this direction at this end. We have to find what is the angular velocity as a function theta of this rod, which makes this angle theta with the vertical. So what we can do is, once again we can find what is the work of the various forces, and this work done is going to be delta kinetic energy. Obviously this is a pure rotation only, this can only rotate, so that is delta Ke about this axis we can find out. When we say delta Ke about this axis, certainly the kinetic energy is not a vector quantity, so it cannot be about in this direction or that direction. When we say that kinetic energy about this axis, it actually means that is kinetic energy because of motion of this body about that axis. So let's see by how much distance this center of mass rises up. We know from here to here is L by 2 and this is also L by 2. So from here to here, if this is L by 2, this is theta, so this is going to be L by 2 cos theta. The height through which it is lifted is L by 2. This is L by 2. This is L by 2. So this is L by 2 cos theta. This L by 2 minus L by 2 cos theta is H. So H is equal to L by 2 minus L by 2 cos theta. Work is going to express itself as the change of potential energy of this rod, that is center of mass is being lifted up. So there is a change of potential energy of this body, as well as there is a pure rotation about this axis also, that is half I omega square will also be generated. Initially it is at rest, there is no omega. So first of all let's find out the work of this torque which is generated because of this force F. We have taken any angle theta to start with. So obviously if this is a force, this is L cos theta. So the torque is at this instant which is being applied is FL cos theta. This is the torque. We know that is small work of torque is torque into d theta. Let's say because of this force there is this angle slightly changes by d theta. So this is torque into d theta. So dW is equal to FL cos theta d theta. If we integrate it, we will find the work of what? Of this torque. Torque because of this force. So this is going to be F is constant, L is constant. This is comes out to be cos theta d theta, 0 to theta. So that comes out to be FL sin theta. So this is what? This is the work done by this torque which is because of this force when this rod has gone from 0 to theta angle. So this much work has been done. Where this work has gone? This work we know that is work and energy, they are interconvertible. So this work has gone, number one, in raising the potential energy of the center of mass. It has raised the center of mass through a height h. Initially it is at a distance of L by 2 from here. Now it is over here. So if this is L by 2, so this is L by 2 cos theta. So initially it was L by 2, now it is L by 2 cos theta. So it has been raised by h, which is equal to this minus this, that is L by 2 minus L by 2 cos theta. This work is being used, that is FL sin theta is being used, number one, to raise the potential energy, that is mg. H is what? L by 2 minus L by 2 cos theta. Change of potential energy plus change of kinetic energy. What kind of a kinetic energy? Rotational kinetic energy. That is half I omega square, because initial omega was 0, so rotational kinetic energy is 0. So that comes out to be, when we write over here, that is FL sin theta is equal to mg, L by 2 we can take it out, 1 minus cos theta plus half I about this end, that is we know ml square by 3 of rod, uniform mass rod about a axis passing through its one of the ends and perpendicular to its length, this thing, omega square. So from here we can get omega. So omega comes out to be 6f by ml sin theta minus 3g by L, 1 minus cos theta. We can also find what is the maximum angle theta which is possible when we start applying this force. Then after some time, after this rod, it may stop over here and we can find the corresponding angle theta. Let's understand that is why this happens and how it is possible that this happens. We see that is torque of this force at any instant is what? This is L. So torque of this force about this axis is force into perpendicular distance between line of force and acceleration. So if this is L, so this is L cos theta. So this is L cos theta. L cos theta. So torque of force about this axis O is F into L cos theta, which is trying to rotate the body this way. If we see, that is, as the theta is increasing from 0 to pi by 2, as the theta goes from 0 to pi by 2 radian, 0 to 90 degree or 0 to pi by 2 radian, that is, value of cos theta will be reducing, because cos theta reduces when theta goes from 0 to pi by 2. So it means the torque of this force about this axis is reducing as the theta is increasing, whereas the torque of this mg at this instant, let's see, mg, this is L by 2. So if this is L by 2, this is L by 2 cos theta, this is L by 2 sin theta, and this torque of mg will try to rotate it this way, and torque is of mg is mg into this distance. This is L by 2 cos theta, L by 2 sin theta, L by 2 sin theta. So torque of this mg is mg into L by 2 sin theta. As the theta is increasing from 0 to pi by 2, then certainly we know that is sin theta also increases. That is, torque of this is increasing, whereas the torque of this force is reducing. So it may eventually attain a maximum theta. We are interested in finding what is this maximum value of theta. If there is a maximum value of theta, it means using our concepts of differentiation, that is, d theta by dt should be equal to 0. Or otherwise also, if theta is maximum, then certainly that is omega should be equal to 0. It has come to a stop when theta is maximum. It means the angular velocity, corresponding angular velocity is equal to 0. Had there been some angular velocity, it would have moved further also. But this is not moving further because we are taking this angle as theta as a maximum angle. So at that instant, omega is equal to 0. If omega is equal to 0, so we can put this omega as 0. So it means 6f over ml sin theta minus 3g over L 1 minus cos theta, that should be equal to 0. So when you solve it, you get tan theta is equal to 2f by mg, or theta comes tan inverse 2f upon mg.